Hello everyone, today we will study about the crop maize. In this topic, we will mainly discuss about the cultivation practices of maize. Before we go into the details about the cultivation practices, we will discuss about few terms which we need to know about maize. Let me begin with the introduction part. Maize, scientifically known as Gia maize lineus, belongs to the family Poaceae. It is considered as the most versatile crop with wider adaptability in various agroecological situations. They occupy the third position next to rice and wheat in area as well as production. Maize is globally known as queen of cereals because of its higher genetic yield potential compared to other cereals and because of its ability to grow throughout the year due to its photothermo-insensitive characters. Now let's see where is its origin. Mexico and Central America is considered to be the primary center of origin of maize. This was given by Watson and Dalwitz in the year 1992, where many diverse types of maize are found. The discovery of maize pollen with other archaeological evidence in Mexico indicates Mexico to be the native of maize. Coming up next is geographic distribution. It is cultivated from 58° north latitude to 40° south latitude. The crop spread and cultivated over 139 million hectares of area and around 600 million tons of maize is produced. USA, China, Brazil, Mexico, India, Romania, Philippines, Indonesia are some of the important maize growing countries. In India, important maize producing states includes Rajasthan, Maize is one of the most important cereal crop in the world agricultural economy. Several products of Now we will discuss in detail about its classification. Maize are classified into 7 groups, mainly based on the characters of the kernels. The first one is flint corn, scientifically known as Gia maize indurata. The entire outer kernel is enclosed with hard starch. Kernel size is large with flat bottom and round at the top. Color may be white or yellow. This is mostly grown in India. The second one is dent corn, scientifically known as Maize indentata. Maize kernels have both soft and hard starch. The hard starch extends on the side and the soft starch is in the center and extends to the top of the kernels. Color of kernels may be yellow, white, or red. This type is widely grown in USA. The third one is popcorn, Maize averta. Kernel size is small. When heated to about 170 degrees Celsius, the grain swells and bursts, turning inside out. At this temperature, the water held in the starch turns to steam and the pressure causes the explosion. The fourth one is sweet corn, Maize saccharata. Sugar and starch make the major component of the endosperm that result in sweet taste of kernels. It is mainly grown in northern half of USA. The fifth one is flour corn, Maize amalaceae. The grains are composed of soft starch and have little or no dent. It is widely grown in USA and South Africa. The sixth one is pod corn, Maize tunicata. Its kernel is enclosed within a pod or husk in an ear. It is primitive type of corn and hence it is less important. The seventh one is waxy corn, Maize cerabena. The kernel looks to have waxy appearance and gummy starch in them because of amylopectin. Now, coming to the agronomic management part, we will start with soil and climatic requirement. Here is the few points what I wanted to mention about the soil requirement. The first one is they perform best in deep, fertile, well-drained sandy loam to silt loam soil rich in organic matters. The second one is they prefer areas where pH ranges from 5.5 to 7.5. The third point is salinity and waterlogging are harmful at almost all stages but affect tremendously during the seedling stage. Now let's see what are its climatic requirements. It is essentially a tropical C4 short day plant. It can be grown up to an elevation of about 3,000 meters above mean sea level. This crop is not suitable when temperature drops below 15 degrees Celsius. Maize require moist and warm weather from germination to flowering. Most suitable temperature for germination is 21 degrees Celsius and for growth is 32 degrees Celsius. Temperature more than 35 degrees Celsius reduce pollen germination. And temperature less than 15 degrees Celsius make delay in silking and also in tasseling. Well-distributed rainfall of about 500 to 750 mm is best for its proper growth. Now, let's know some popular varieties of maize. The first one is fodder maize, and among the popular varieties of fodder maize, African Tall J1006 can be mentioned. And the second one is popcorn, Amber Pop, BL Amber Pop, Pearl Popcorn. And Jera 3 is the most popular variety that can be cultivated in flood-prone area. And among the drought-resistant variety, Prakash and Megha can be mentioned. And among the hybrid varieties of maize, Ganga 1, 2, 3 and 102, Ranjit, Himalaya VL54, Ganga Safed 2, Ganga 4 and High Starts. And quality protein maize, also termed as QPM in short, includes Shaktiman 1, Shaktiman 2, Quality Protein Maize 1, Protina, Ratan and Shakti 1. Now let's start about the cultural practices of maize. So what point we need to know during land preparation we will discuss now. Well aerated, friable, moist, weed-free seedbed provides better contact between the seed and the soil, which provide uniform germination. Maize crop require plowing up to a depth of about 20 to 25 cm, followed by 2 to 3 harrowing. Land should be well leveled and be free from crop stubbles. Now let's know about its optimum sowing time. There are three distinct seasons for the cultivation of maize in India. The first one is Kharif maize. The optimum sowing time for Kharif maize starts during the month of June and may be continued up to July. 85% of the rain-fed maize growing area is under Kharif season. The second Kharif season crop, but in the past few years, Rabi maize has gained a significant place in total maize production in India. This method is considered as best planting methods during monsoon as well as in winter, both under excess moisture as well as limited water availability or rain-fed conditions. Sowing or planting should be done on the southern side of the east with ridges or beds. The second method of planting is zero-till planting. Under such condition, one should ensure good soil moisture at sowing and seed and fertilizers should be placed in band using zero-till seed-cum fertilizer planters with furrow opener as per the soil texture and field conditions. The third point is conventional till flat planting. Under heavy weed infestation where chemical or herbicidal weed management is uneconomical in no-till, and also for rain-fed areas where survival of crop depends on conserved soil moistures, flat planting can be done using seed-cum fertilizer planters. The fourth one is furrow planting. To prevent evaporative loss of water during spring season from the soil, it is always advisable to grow maize in furrows for proper growth, seed setting, and for higher productivity. The fifth one is transplanting. Under intensive cropping systems where it is not possible to vacate the field on time for sowing of winter maize, transplanting is an alternative and well-established technique. Now, let's see about the seed rate. 20 to 22 kg of seeds for hybrid maize is sufficient for 1 hectare of land, and 18 to 20 kg seeds for composite varieties is sufficient for 1 hectare of land. Seed soaking overnight in warm water, that is 45 degrees Celsius, at the time of seed soaking enhance seed germination, provide better plant stain, and healthy crop. Now, let's see how much sowing depth we should maintain. Centimeter between rows and 20 to 25 centimeters between plants should be maintained. Now let's see about the manures and fertilizer application. Incorporation of 10 tons FYM 10 to 15 days prior to planting provides better environment for crop growth. Blanket recommendation of 120, 60, 40 kg per hectare of NPK is recommended for hybrid maize, and 80, 30, 20 kg per hectare of NPK for composite varieties. Zinc deficiency causes white bud in maize. Therefore, zinc sulfate at the rate of 25 kg per hectare at the time of sowing is recommended. If not possible to apply as basal, foliar spray of 0.5% zinc sulfate at critical stages is recommended. Full doses of phosphorus, potassium, and zinc should be applied as basal. Nitrogen should be applied in 5 splits as given in the table for higher productivity and higher use efficiency. Nitrogen application as grain filling results in better grain filling. Now, let's see how nitrogen application should be done in 5 splits. The percentage of recommended dose of nitrogen required in each stage is given in this table. The first stage is basal, and at this stage 20% of recommended dose of nitrogen should be applied. And in the second stage, that is fourth leaf stage, 25% of recommended dose of nitrogen should be applied. And during the 8th leaf stage, 30% of recommended dose, and during the selling stage, 20% of recommended dose of nitrogen should be applied. And during grain filling stage, 5% of the recommended dose of nitrogen should be applied. If nitrogen is not applied in 5 splits, apply quarter of the dose as basal. Top dress half of the dose of nitrogen on the 25th day of sowing, and the rest is to be applied on 45th day of sowing. Now let's see what cropping system we can follow in maize. Crop rotation can be practiced successfully in areas where there is proper irrigation facility. Maize can be rotated with crops like wheat, potato, toria, sugarcane, gram, bersim, lucerne, barley, and oats. Crops which can be grown successfully as intercrops includes short duration varieties like short stature variety of maize perform better under intercropping situations. And pre-plant application of non-selective herbicides like glyphosate at the rate of 1 kg active ingredient per hectare in 400 to 600 liters of water, or paraquat at the rate of 0.5 kg active ingredient per hectare in 600 liters of water is recommended in case of zero-till maize production. If herbicides are not used, hoeing and hand weeding on 17 or 18 days of sowing proves effective. The causal organisms are stem borer and pink borer, and the control measures of both the causal organisms includes foliar spray of 0.1% endosulfan 10 days after germination. Kylo can be controlled by release of 8 trichocards per hectare at 10 days after germination. The third causal organism is soot fly. Seed treatment with imidacloprid at the rate of 6 ml per kg of seeds is recommended. Next is about disease management. The first one is Maize leaf blight. This can be controlled by using mancozeb or ginef at the rate of 2.5 gram per liter of water. The next one is common rust. Spray of mancozeb at the rate of 2.5 gram per liter of water at first appearance of pustule is advisable. The third one is Persicum leaf blight. This can be controlled by using ginef or menef at the rate of 2.5 to 4 gram per liter of water at 8 to 10 days interval. Next is downy mildew. This can be controlled by seed treatment with metolazil at the rate of 2.5 gram per kg of seed and need-based foliar spray of systemic fungicides like metolazil at the rate of 2 to 2.5 gram per liter of water at first appearance of disease symptoms. Next, we will see about harvesting. The grain cob is harvested when cob seed turns brownish and the seed become fairly hard and dry and do not contain more than 20% moisture. The cob is removed when the plants show maturity symptoms. Next, we will see about how threshing should be done. The cob seeds are tear off and then dry them in the sun for about 5 or 6 days to reduce the moisture to about 10 to 12%. Cobs are typically dried up to 15% moisture when it is expected to be marketed right away. In conventional selling methods, grains are removed from the cobs by beating them on the ground. Mechanical sellers can also be used. The seeds are cleaned by winnowing. Green maize fodders can also be used as a feed for cattle. Next, we will see about storage and some storage structures. Storage structures may consist of bins with thatched roof or brick roof and ferro cement bins. Conventional storage methods include crypts and open and closed mud plastered baskets. And in general, the type of storage structure depends largely on the farmer's financial status. Following all these cultivation practices, what I have mentioned earlier, let's see how much yield we can expect. About 3 tons of grain yield can be obtained under rain-fed situations, and about 5 tons per hectare of grain and about 10 tons per hectare of straw yield can be obtained in irrigated conditions. This much is what I wanted to share about the cultivation practices of maize. Now I would like to conclude with these few words. Maize is an important cereal crop in the world after wheat and rice. The importance of maize lies in its wide industrial applications besides serving as human foods and animal feeds. As the demand for maize is growing globally due to its multiple uses for food, feed, and industrial sectors, we need to produce more from same and even less resources. Introduction of high-yielding maize variety, adoption of proper agronomic practices starting from the site selection, land preparation, variety selection till harvesting of the crop is worth mentioning for enhancing the production.